We now turn to the part of Chapter 1 where we focus on the R code itself. Before we get there, I just want to mention that why should you bother to learn the R language? Well, there's a lot of jobs available where knowledge of the R language is a tremendous asset. So if you have quantitative finance training coupled with the ability to program in R or Python or some other language, that often deeply enhances your capacity to land the type of job that you'd like to have. The long history of computer programming languages, it's often difficult for entry-level quants to realize that, yes, I'm an old professor, but in my lifetime, when I first was introduced to quantitative analysis, we used punch cards and things like the internet didn't exist. And programming was much, much more challenging. Low-level languages or machine-level code, they tend to be very powerful, but very difficult to actually code. High-level languages are much easier to use. In the mid-1950s, Fortran came along, and it was a very high-level language which opened the door for many quants to be able to program without professional training in the skill of programming. Following Fortran, the language C came about, and then C++ is basically an enhancement of C. Combines high-level, easy to use, and low-level, very powerful. It's fast, it's object-oriented. C++, I still use to this day when I need computational speed. There's a package in R known as RCPP, which easily allows you to combine R programming with C++ programming. And so you can easily link between those two languages, as well as many other languages. Your ability to code allows you to rapidly develop applications, which makes you very valuable for the particular company where you work. When you're learning R, there's an interesting tension between autonomous versus heteronymous. Autonomous basically means you as the student has the freedom to act independently. Training materials are compiler independent. That is, you could do this analysis in Python, C, C++, R, or whatever other language that you may want to use. Heteronymous is where the professor basically subjects you to an external standard. The training materials are specific to one compiler. My preference is to be somewhat heteronymous in the sense that I will be illustrating all of this material using the language R. You're more than welcome to use a different language. I just don't provide any support of this material for languages outside of R. The deliverables throughout all of this material is what I call simple prototype programs. Many of my entry-level R code the last word in the code name will be test, emphasizing that this is simply a test program. It's not the final actual implementation. To actually implement things, it's amazing the level of exhaustive error trapping when you get into real-time data feeds and other challenges. There's a whole lot more involved. The focus here is, again, to have deployable code that's easy for a novice to understand and actually begin to learn to code. This is an excerpt from RStudio, the platform that I'll be using. There's 4 windows that are typically visible. This is illustrating the first program, module 1.1 program layout. And so in the file window, you'll notice that the actual R code is there. The pound symbol is basically, those are comments that are not actually used. The console window is where you can see the results of the program actually running. The environment window is where you can see the variables that are produced as you make your way through the particular code. The information window basically lets you know what files are there. If you produce some plots, it'll show you those plots. And this help tab is very useful. If you don't understand a particular name that's being used, oftentimes the help is a first start. Obviously, in today's environment, it's many times much more efficient to go out to do an internet search, and after a while, you'll begin to see familiar websites like Stack Overflow and others that provide just incredibly valuable insights on the particular task that you're trying to master. Under new file, the thing to notice here is that the RStudio supports R scripts, which is primarily what we'll be focused on. But you can do an R Markdown where you actually produce documents with your R code. Shiny develops web applications, which is very useful. You can read in a C file or a C++ file. There's a package called RCPP, which is very useful in linking C++ files with R code. And you can do a host of other linking of R code with, say, Python, SQL, and other important pieces of code that you may have from other sources. The second module that's provided in this particular chapter 1 is heating degree days. This is simply a way of illustrating reading in a file and then producing a simple plot. This particular code illustrates some challenges with managing dates, and we'll get into that much more detail in module 3.1. There's a couple of appendices. One is I recommend that you begin to build your own repository. I'll be providing you a lot of code, but this particular code I'm assuming is in a subdirectory QF repository or quantitative finance repository. I recommend that perhaps you use the first letter of your initials or something. And what you want to begin to do is build your own repository. You can think of this sort of like Lego blocks. You're going to be building a lot of things, and the more Lego blocks are, more things you have in your repository that you can quickly draw on, the better. The way we're going to manage this is very modular, and so there are 14 chapters in this particular book, and each chapter has several different modules that go along with that are supported with R code. And each module will be in a separate folder, and the folder will stand alone. You don't have to link to some master repository, although that's very inefficient as far as the different functions that you use over and over. It's also incredibly easy. It's much easier to have these in modules so you can just run them independently. I have certain preferences. You're obviously welcome to use whatever preferences you want. I tend to indent 2 spaces after curly brackets. The open curly bracket is on the same line. The closing curly bracket is on a new line. I use blank lines very rarely. Back in the day when people would often print out your computer code in order to try to find mistakes and errors, it produced an enormous amount of paper. It's just code becomes very, very long, and so I don't like to use a whole lot of blank lines. If I need a space, I'll include a comment. I recommend you put your name on the first line of each file. Makes it much easier to know who authored what. Our function code I will typically put in a separate file. The test code will be the entry point. So if you're looking at a module that has 8 different pieces of R code, open the test file first. You'll typically find another file with the last word function or functions, and it will have the particular functions used. I tend to name variables lowercase or both uppercase and lowercase. I err on using longer names. Why not make it very readable for the person coming behind you. Often the person coming behind you is in fact you, but you're coming back 5 years later to a particular module and you don't remember what you did if you don't use long names. And the function name, sometimes I begin with the uppercase for each word just to make it more clear what's going on. And again, this is just an illustration. The green here is a comment. So that's a piece of comment code. This is some code that we'll explain in more detail later. This basically, these first 4 lines will show up in most of the code that I do. Mainly this is cleaning up the environment is line 5. If I produce a lot of graphs and other things, line 7 actually gets rid of the old plots, and line 6 clears out the console, making it easier to check for errors. Although this may seem trivial, you'll be amazed at how you'll get yourself tripped up if you don't take out the trash, so to speak, at the beginning of the program. You'll have legacy errors that just stay there until you clean it out. I have a preference for Times New Roman, and so the output that's produced, if I put in the parameter, if I make it Times New Roman, the output that's produced will typically be in Times New Roman. Lines 10 through 12 illustrate the use of long names. It's just easier to know that line 10 is a stock price and that it's an input. As you see here, this is a geometric Brownian motion call and put boundary conditions that we'll see, I think, in module 5.1. But you'll notice that there's no extra lines, but this code is also very readable. R is good with holding things in vectors and matrices, and I could often compress this in much more cryptic code, but this is very readable. Line 81 is a loop, and it loops through a set of variables and vectors, more which will be described in detail more in the future. You can build functions with R, and this is just the illustration of a simple function, the present value of $1 using a continuously compounded interest rate with some fraction of a year to maturity. The assumption is that rate is an annualized continuously compounded. It's inputted as a percent. It's made a decimal and then multiplied by year, and then that returns the present value of $1, discounting at the continuously compounded rate. You can do other functions with passing in what we'll see later as a data frame. Again, there'll be many things that we cover